Welcome to The Explainer. Today, we're digging into a fascinating discovery out of Stanford that really challenges everything we think we know about AI performance. Turns out, the model itself, it might not even be the most important part of the whole equation.
Let's just start with this number right here, 6, as in 6 times. This represents a 6-fold performance gap. But here's the kicker. This gap was found between two AI systems using the exact same model, on the exact same task.
So this all comes from a new paper out of Stanford's IRIS lab, a 600% difference in performance when the model is a constant. I mean, that's a massive puzzle for the whole industry. It pretty much screams that we've been looking for performance boosts in all the wrong places.
Right, so if throwing a bigger, better, more expensive model at the problem isn't the answer to closing this huge gap, then what is? What have we all been missing here? Okay, let's get into it. Well, the answer, it turns out, is in a part of the system that we almost always ignore. It's a piece of the puzzle that's doing most of the actual work. It's called the AI harness.
So what on earth is a harness? Well, think of it as literally all the code that wraps around a model. It's the thing that's feeding it information, managing its memory, connecting it to tools. Basically, it's the puppet master telling the model what to do and how to behave out in the real world.
And this table here just lays it out perfectly. The model, that's the raw reasoning power. It's like the engine in a car. It's got all the horsepower. But the harness? Man, the harness is everything else. It's the chassis, the steering wheel, the gearbox, the tires. It's what actually lets you use all that horsepower and turn it into real performance.
And here's the crucial point. For years, we've all been completely obsessed with the engine, right? Getting a bigger engine, a more powerful engine. It's what gets all the headlines. But this research tells us, loud and clear, that the rest of the car, the harness, is where the real work gets done. It's where these huge performance gains are just sitting, waiting to be found.
Okay, so building these harnesses by hand, it's a total pain. It's slow, it's really complicated. So the researchers at Stanford thought, hey, what if we could get an AI to do it for us? And that's how they came up with a system they called meta-harness.
Now, people have tried this kind of thing before, but they usually just gave the AI a little summary of what went wrong. Meta-harness flips that completely on its head. Its big idea, the core innovation, is to give its optimization agent access to everything. The whole unfiltered mess, all the source code, all the execution logs, every single past attempt.
And this chart just shows you the insane difference in scale. The old way, you were looking at maybe 22,000 tokens of context. With meta-harness, we're talking up to 10 million tokens. That's not just a little better, it's, like 3 orders of magnitude more data to learn from on every single try? It's a whole different ballgame.
And what it does with all that data is pretty slick. It acts just like a senior engineer debugging some gnarly code. It doesn't try to read all 10 million tokens at once, no way. Instead, it scans the error logs, zooms in on the problem, reads just the relevant files to figure out the root cause, forms a hypothesis, and then proposes one tiny, targeted fix to the code. Then it runs the test again, sees what happens, and just keeps repeating that loop.
So you might be wondering what happens when you let an AI basically debug and improve itself like this. Well, the results are just stunning. Absolutely game-changing. On a really tough text classification benchmark, the harness that meta-harness designed boosted accuracy by 7.7 percentage points over the human-designed one. I mean, in this field, that's not just an improvement, that is a massive leap forward.
And check this out. It wasn't just more accurate, it was smarter. The new and improved harness used 4 times fewer tokens to get to the right answer. So it's not only better, it's dramatically more efficient. But honestly, this next part might be the biggest deal of all. On a coding benchmark where the AI has to act like a software developer, meta-harness completely changed the economics of AI. Okay, so get this. They took Claude's little model, Haiku, the cheap, fast one, and let meta-harness build a custom harness for it. The result? It became the #1 top-performing agent in its entire class. Let me say that again. A better harness made a small, cheap model competitive with systems running on much larger, more expensive models. This pretty much shows that harness optimization can be a direct substitute for model scale.
So this isn't just some academic paper. This has real practical implications for anyone out there building with AI today. So what's the new playbook? What should you take away from all this?
Okay, the new playbook is pretty clear.
First, you have to start treating that harness code like a real product, not just some temporary scaffolding you're going to throw away. Second, you've got to invest in logging. You need those detailed traces to actually debug and optimize. And maybe most importantly, before you go spend a ton of money upgrading to the next-gen model, just stop. Try optimizing the harness you already have, because that's where the biggest, easiest wins are probably hiding.
Which really leaves us with one last, kind of provocative question to think about. Is it possible that the model you're using right now, the one you're paying for, already has all the performance you need? And maybe it's just been trapped this whole time, waiting for the right code, the right harness, to finally set it free.